Okay, so good morning, everyone. Thanks Lorna and Wim for having me here. Thanks for coming to this talk in the PHP room, which is called My Site is Slow, What Can I Do, and Profiling PHP Applications. So this talk will be all about speed. And with that, I mean the speed of your web application, how your web application is going to be fast and also maintained to be fast. So we'll talk about why speed actually matters, how you can measure it, that you actually know how fast or slow you are, and how you can find out where the problems are, how you can fix them, so that you actually get better in speed. Before we start with that, a few words about me. I work at a company called ResearchGate. It's a social network for scientists and researchers, very international, based in Berlin. It's all about researchers sharing their publications and data and everything with other researchers for free. We have like a few amenities in our company, and sometimes people come visit us, and we are always looking for new people. So if you're interested in working in a very good, interesting startup, talk to me afterwards also. In general, if you have any question during the talk, just like raise your hand and interrupt me, and we can handle them. And also we have plenty of time for questions in the end afterwards. The slides will be on Speaker Deck uploaded, and they also be like linked on Joined In, where you also can have feedback on the talks and all other talks you are seeing in this room at this conference. And this helps greatly all speakers so that they can improve their talk. That also helps Lorna and Wim to organize the PHP room and see what you're actually interested in. And in the end, it also helps you because you get better content next year when you come back. So, speed. Why should you actually care about it so much? Because it is really important. Yeah. But in seriousness, the last couple of years there was lots of research done on how speed and performance of a web application affects users and engagement of these users. And in the end, also money made with web applications. And the results of all of these studies were that every millisecond counts. And this is not a typo or misspoken. I am speaking of milliseconds, not seconds. All of these, for example, there were studies done where a company said, okay, we are just going to make our site 1 second slower. You would say, okay, 1 second, the average like response time of human beings is like 300 milliseconds or so. So 1 second, it's not that much. That's it. But 1 second in delay in page rendering time and everything in this study then led to 7% loss in conversions, which is quite a lot, 11% fewer page views, and 16% decrease in customer satisfaction. And these customers are usually that are not satisfied anymore usually don't come back. They just go to your faster competitor. Speaking in more general terms, for example, Yahoo tried that. They make their homepage 400 milliseconds, only 400 milliseconds slower for a certain user group of users. They just built in a sleep for some users. 400 milliseconds. And that led actually to 9% decrease in traffic in this target user group. And these users also were not coming back. Same with Mozilla. They had, I think, their homepage where they could download Mozilla Firefox. They sped that up at some point, and for some reason managed to make it 2.2 seconds faster. That's quite a lot. But you would not expect that this will and then lead into 60 million more downloads of Firefox in this group. So speed is really important. But what is in a web application actually page speed? Of course, the first thing that a web application is influenced by is the server. And that's quite nice because the server is completely under your control. And usually it's a request, an HTTP request coming in, then you have your big PHP application or whatever kind of web application, and then in the end you send a response out, which is HTML, JSON, depends what you do, and then you're done. Okay, usually your web application is a bit more complicated than just one Apache server with PHP or one NNX server with PHP. You may have several servers and a load balancer in front of them. Also, your PHP application is probably not only one script with 50 lines of code, but a bit more complex. So you have different controllers, different services, different layers in there, different modules that all can influence and make it more complicated how long a request on your server actually takes. And then Usually it's just not only an application in PHP that you're doing, but you also have a database you're talking to, some other HTTP services, maybe also some APIs that are somewhere in the cloud, like the Facebook API or so. You're talking to caches, to the file system, whatever. All these contribute to your page potentially getting slower. So you have to think about that and measure stuff there. Unfortunately, there is more. You not only have the server where your application is running on, and that is completely under your control in most cases, but you also have this cloudy thing called the internet. So once you actually rendered some HTML or rendered some JSON and send it back to your client, it has to be transported somewhere over the internet to the browser of the client. Also, you have stuff like DNS lookup, SSL handshakes that all contribute to load times as the user sees it, because he clicks on a link and then stuff happens, and then he gets something back. Once the content, the HTML content, for example, is at your customers, at your client side, then there's something like called the browser that can also greatly influence speed. There are very fast browsers nowadays, like a new Chrome, a new Firefox, IE11, whatever. Like modern browsers are very, very fast, but there are also tons of people who use legacy browsers still, like IE6, 7, 8, or even worse. Then the content is there in the browser. The browser has to parse the HTML, has to render it has to fetch CSS, apply it to the HTML, it has to fetch and execute JavaScript. All this also leads for the user, of your users, to actually perceive the site as slower. He has to fetch images. And if you look at this whole thing in total, you see that the anatomy of a web application is usually that only a very short percentage of the speed the user perceives is actually due to the backend, to the server having to do some computational work. Most of the stuff is actually transporting it over the wire, fetching all these images, gigabytes of CSS and JavaScript that you have on your page, and executing that. So what happens on your server is really important, because if your server takes 5 seconds to do something, your user probably already closed the browser window or went somewhere else. But the rest is as well. So if you want to make our site fast, first step we have to take is we have to actually measure how the status quo is. Who is doing this performance measurement, that you have metrics, how long your user actually, or how your web requests take? It's maybe like a third. Hopefully after this talk next week, a few more people are going to start measuring actually their load times. If you start that, you will see that it's really, really painful at first, the numbers you are seeing there. Because you have the effect that on your machine, everything is fine. You have a good internet connection, you are close probably to your servers where they're sending. You have a powerful new machine with lots of memory, good CPU, modern browser, everything is great. Then, unfortunately, the reality is there are people with pretty old computers, probably not as old as this one. There are people using your application over phones, especially if some of users coming from Africa. A lot of people there have just small feature phones or very low-cost smartphones, and they are browsing the web through it because they don't have anything else there. A lot of people actually use quite old browsers, especially China has still like a, I don't know, 10%, 20% IE6 rate. So the figures are from, I think, half a year ago or so. It may be a bit lower, but in China it's probably due to pirated Windows XP versions that are not allowed to upgrade, and they don't. I don't know why they don't install Firefox, for example, but they don't. Also, the internet speed in various regions of the world is completely different. In North America, Europe, you have pretty good latencies, in parts of Asia as well. If you go to Africa, South America, that may be completely different. So in order to actually see how and measure how your web application is for your users, because that's actually what counts, not how you at your laptop next to your servers are seeing the performance, but how your users are seeing them, you have to measure at your user's side. There are several solutions already for that you can just use and pay for it. For example, there's FOSDEM who's offering that. You basically add in a bit of JavaScript and then pay them a lot of money, and then you get nice graphs out of it. There's Liberato, also one hosted platform as a service solution. But you also can do it yourself. It's not that hard, because most modern browsers offer already APIs for that you can, in JavaScript, actually get all the data you need out there. There is a navigation timing API that has been around for a couple of years already, and all browsers support them. Where you basically can get all the timings from a web request. From when the user actually clicked on a link to all SSL handshakes, all DNS lookups, to actually establishing a TCP connection, sending the request to your server, how long your server actually took to generate the response, when the first byte was received at the client, to all the DOM processing it does, all the fetching of something, until really the onload event was thrown. If you have older browsers that don't support this API, there are libraries out there, for example, called Boomerang from Normal, you can find on GitHub, that do this help you with doing that for older browsers by just inserting JavaScript timers at the right point in your HTML. But for modern browsers, you have this API. Same, which is not supported by all browsers yet, is the resource timing API. It's basically like a navigation timing API, but you just get all the data of single resources that your web application is fetching, like all CSS requests, image requests, AJAX requests, and so on. And there you also get all the data when a request was started, data about redirects, DNS lookup, etc., and also how long each request took. And if you also take this together, you can aggregate this into very nice graphs. So we have all these timings now in your JavaScript, in your web application, in the client. Somehow you have to get it back to your server because you want to measure it and aggregate it in a central place. The way all these platform as a service providers are doing it, and the only way to get it back is to just send a tracking request with all this data back to your server. Could look like something like tracking.yoursite.com, then maybe an identifier on what page you are, and then you can send all the timers to this request. If you are a bit more about security and don't want users actually hacking these requests and script kiddies finding that out, you can create hashes about that to make it a bit more secure or less prone to fiddle around with. But from our experience, nobody does this anyways, and usually it's fine. And if there are like crazy values, you just ignore them. So we have this request coming in somewhere. Of course, since this is just a tracking request, you don't want it to take like 500 milliseconds or so for even this request to complete and write data somewhere to a database. So from our experience, a good solution is just have an Apache Nginx server listening to that on this host name, and that just returns an empty response, HTTP 200. And then you can write all this data with these parameters here to the access log, which normal web server does anyways, and then have a log daemon or something going through this access log and writing the data actually to your tracking graphing backend. A good daemon, a good solution for that is, for example, Logstash. Logstash is a small daemon that doesn't take lots of CPU and memory. You can just install it on a server, and it's able to basically get data in somewhere, transform it, and put data somewhere else. And then there's lots of plugins that you can configure to actually tell them where to get the data from, how to transform it, and where to put it. So the setup would look like you have your application in the browser, some JavaScript that gets all those tracking parameters over the APIs. Once the page was loaded, it sends a tracking request to your small tracking server with just a web server. This just writes this request in an access log, and you have Logstash listening on this access log, which then sends the data somewhere. Where there are lots of solutions to get actually tracking data and graph it. A nice one and very flexible one is called Graphite that we are using. You can just put timers and counters in there and get nice graphs out of it, and can correlate all the kinds of graphs with each other and have lots of math you can apply to it to really find out and get the data in the graphs like you need to. So that's just some impressions of the site. So Logstash would then just tail on this access log and send the data to Graphite, and this .d thing is just a daemon in there that makes Graphite better, scaling better. It's not that important. So configuration-wise, it's very easy. In Logstash, you have an input, which is basically your access file. You have a filter, which says, okay, I have my pattern of my access log, so I'm just having a regular expression over it, and put, for example, the page information in this page field and the connection time in this connect time field and so on. And then I have an output where I just send all this data to Graphite. For example, my connect time here as a timer. And voila, you get a nice graph out of it. Additionally, what you also can, so this is actually then timings of what your users are perceiving as page speed. This is really awesome. What you can do additionally is use something like a web page test. It's also a free open source tool. You can use it hosted at webpagetest.org, I hope. If not, it was .com. Just Google it. It's also a project done by Google, and you can just download it, install it on any kind of servers you like. So you can buy cheap hosted hardware somewhere in Asia and in South America and everywhere else, and just run the daemon there, and then give it some URLs, and you get page speed metrics back with a very detailed view on how long each took with screenshots and everything. So this is also a very nice project. Of course, this is not real user timings and real user metrics that you get, but it's also a nice indication of how your web page how long the load of your web page takes. So through that you get complete timings. Can we measure more? Because actually what happens on your server, we didn't handle very much. You of course have the back-end response time from the navigation timing API, but maybe we want to get into more details there. So it's a good thing to don't stop at that and also measure stuff within your PHP application. For example, how long do our database queries take in your PHP application? Just add a start microtime on top before that, end of microtime, and send this data to Graphite as well. Same with HTTP calls you're doing to some other services, or the amount of time your PHP application takes actually to render data from an array where all the data is into HTML with all this escaping and so on, and templating you are doing. Cache times, and so there are lots of things you can measure there, and sometimes also dependent on your application that can help you see and find out bottlenecks. You also can make all these metrics more fine-grained. Of course, it's kind of interesting to say, okay, my average load time over all pages on my application is 500 milliseconds. Awesome. But maybe you have some pages that are very, very fast, but you also have some pages that are very, very slow. So just the mean time doesn't give you a lot. So it's good to make these metrics more fine-grained, for example, by pages, of course. Maybe also by browsers, because different browsers can have hugely different performance characteristics, especially considering JavaScript, HTML, CSS. Maybe also by country. It could be interesting to see how is the load time of my application in China compared to the United States. Probably very different. How is the load time compared to logged in and logged out users? Because probably logged out in users are more important than logged out users. How is maybe the load time for heavy users that have lots of data in there? Maybe they are especially slow, but they're also especially important because they're very active. I could add slow query logs from my databases to that and aggregate with over that. I could add logs of my load balancer to it, especially if I have a service-oriented architecture. I usually have load balancers a lot of places. Like I have maybe a load balancer before my web servers, and then I have some HTTP services that I'm calling from my PHP application that also have load balancers in front of them. If you're using HA proxy, you can just tail over your HA proxy log or over your load balancer logs, where you usually have all these things, and then also just pass all the data out and send it to Graphite as well. Basically, the rule of thumb there is that every kind of log one of your components is producing is a potential good source for getting metrics out of that you can deduct performance indications from. So in the end, you have all kinds of things and services sending data actually to your graphing backend. And then, if you have all these shiny metrics, you should look at them and define goals. Define a goal, what you want to achieve, how fast you want to get, and then define a deadline and define the steps, what you want to take. So, you know your probably not as fast as you thought to. Like when we started this whole performance thing, probably like a year ago, we had really, really bad load times, unfortunately. Like some pages were like up to 6 seconds. Backend times were also sometimes over 1 second, so it was really bad. Then you have to somehow find out where the problem actually is in order to fix it. And there comes profiling in. Profiling means I have all these metrics that tell me this takes a few hundred milliseconds. If you have more fine-grained measurements, like for example, you measured the amount of database calls and then SQL queries, how long they took, you may have a better idea already. But if you need a really detailed view in what your application is doing, then you have to profile it. There are several tools out there for PHP. The first that comes to mind is Xdebug. Xdebug, written by Derek, is a really great tool to find out locally on your development machine what's happening there. So it does not only have the possibility to set breakpoints and then walk through the code while it's executing, it also has the possibility to create a profile of your application where you see all function calls that were done, how often they were done, how much memory they consumed, and how long they took. If you installed Xdebug, it's just a Packer extension. You can set it in INI setting, profile, enable, trigger, so that every time you have this query parameter Xdebug profile, so LUL, it just dumps you a profile. You should not do it on every request, because then you probably will run out of disk space very quickly. They take a lot of space on your disk. And then you can use a tool like, for example, WebGrind or I think QCacheGrind or something to have a look at this big profiling file. And then these tools give you a list of all functions that were called. And yeah, it's very small here, but it's not that important. And how long they took, and you can also click through these functions and see, okay, this function took 500 milliseconds. What was actually, did this function call other functions? And this can be very useful to pinpoint. As I said, use it locally on your dev machine only, because as soon as Xdebug is activated or installed even, it has a performance, it hits performance, it makes performance worse. So if you should never install Xdebug on production machines. If you have something that you can't really see on your dev machines because you don't have enough data, or you really don't know how the user actually got to this point, why the page was so slow, there is a tool called XHProf that you also can install on production machines. If it's just installed, it does not make performance worse or anything. It's just not, as it's not there. But you can then activate it for a small subset of requests on production. These requests will be a tiny bit slower, like maybe 5% or so. But for like 1% or 0.1% of your requests is probably fine. An additional benefit of getting this profiling data is worth it. And then, as with Xdebug, there's also a tool that gives you all this information, and the profiles are written into a database, MySQL, for example, and then there's XHGUI, where you can get this nice graphs out of there, how long everything took, and all this function stack traces again. So basically the same output as Xdebug is doing. XHGUI also has additional IC dependency core graph that you can render out of this data, so you see where your hotspots are, what is called often, and what calls what. And also has the possibility, because it's all in a database, to give you historic data to see, did I get slower with these profiles or faster? You can maybe see all profiles of one session, all profiles of one page, and so on. If memory is your specific problem, there's a tool called PHP meminfo that basically you can just call a function at any point in your script, and this then gives you a memory profile. What variables are actually allocated at the moment, how much memory they consume, and you may see memory leaks and debug memory leaks through that. Who's using a framework like Symfony 2 or Zen Framework 2? Or okay, most of you are. Most of these frameworks, as Symfony or Laravel or Zen Framework 2, offer debug toolbars that you usually see in development. In Symfony 2, it's here at the bottom, and you have some basic data there, how long a request took. Like here it's 400 milliseconds, how many memory it consumed. And you also can hook in stuff like doctrine there. Then you see the kind of queries, SQL queries you did. You see exceptions that are happening. You can hook your caching layer in there, and you see then cache requests and so on. This also gives you a nice timeline view with where actually on a higher level, what controllers were executed, how long each controller took, and more. You see routing information, how many emails were sent. And this can also be a very useful tool in development to see what is happening. So I urge you, if you have problems there, take a look into it. And then what some people don't know is that you also easily can extend these tools, especially with the Symfony one. And you also can use it easily with maybe like half a day of work without using full Symfony framework. With extending it, I mean, there's probably lots of things in your application that could be useful to display there. It could be, for example, that you are talking to RabbitMQ and sending events there. So you may want to debug this as well and log this as well, how long this takes. Or any kinds of other things. And let's see if my internet connection holds, and I can show you the example of how we extended this toolbar. Browser. Okay. Yeah. Resolution is a bit small, but you can see the toolbar down here. So we have the usual, like for example, load time and memory consumption, information about the current user, how we log down here, all Postgres queries, all MongoDB queries we're doing, all HTTP requests, how long they took, all requests to our cache. We don't time them anymore because actually everything was under 1 millisecond, so it was not that useful. But we have 202 cache requests. And of course, we can also click on everything. We can see the requests and queries that are happening, see more details about them. Also, how long they took all the time, if they got, for example, if they were sent to a master or slave server. We have information about all the components that are here in our page. So how we build pages would be a whole other talk. We have very small components on the page that we assemble together dynamically if needed. And here is a nice graph of all these components on a page, and it shows you then what took how long and why it took that long and where it was called. And this is also then very useful information for our specific application. Other than that, yeah, exceptions. I hope there were none. No. Also very interesting is what experiments the user is currently running. We are doing lots of A/B testing. And these A/B tests also can influence performance greatly. So with that we log, for example, this is now in this follower experiment, so we may get more information why he was so slow compared to other users. That's that. Yeah, we saw already the screenshots here. We also extended the timeline view a bit with more metrics for our application. So we are also not using Symfony, stock Symfony. We are basically using some Symfony components and then also the toolbar. The nice thing what we then also can do with this thing, of course, profiling all that takes also a bit of time and a bit of memory because you have to remember all the SQL queries, all the cache requests and everything that you are doing. But you can also use it in production for a subset of requests. Of course, you should not show these users a toolbar then, but you can still collect all the data and then dump it somewhere, save it somewhere in a database. The saving in a database you should do maybe in a shutdown handler so that the request for the user is already finished and does not wait for like these 20 milliseconds to write this whole big collection of data. But this is also very useful for getting more information out of your application. Of course, if you want to not do it all on your own and pay for something, there are already other profiling tools available for as hosted solutions. For example, my friends from Profu have a profiler that is based on XHProf, and they extended it, open sourced some of it, and then built a very nice front end that shows you also all kind of the information out that you can get out of the stack trace. Similar to that is Blackfire.io from Sensor Labs, the creators of Symfony. That is basically the same concept, but just other visuals and a bit more tied to Symfony. There's also New Relic, which also works great with PHP. Regardless if you're saying, okay, I'm just doing a bit of the stuff on my own, or if I'm using such a hosted platform, everything is fine as long as you do it. So now you know why it's slow and where it's slow and what you have to change maybe in order to make it faster. Now you have to fix your problems, and unfortunately that's something I can't really help you with. This is very specific, sorry, this is very specific to your application. I just can tell you one thing is always important: keep up to date about performance. There's lots of content out there, lots of articles out there, lots of best practices, and these best practices change also over time as browsers evolve, especially with front-end performance. So there's one good site I like is Perf Planet, which have lots of great articles also from people working on performance at Facebook, at Google, and at Etsy and other small companies. So it's always good to have this on your feed reader or something. We have a couple of 15 minutes left, so I can maybe still help you a bit with your performance problems, because these are just a collection of random hints what you can do to make your performance of your application better. It's by no means complete, and some stuff may not apply to your application, and there's probably lots of things missing. There are a few obvious things you should think about. For example, enable gzip, so that reduces greatly the amount of things and data that goes over the wire for your users. Also, it would be good to enable gzip in your own network. So if you're calling another HTTP service somewhere, and this is transporting, I don't know, 500 kilobytes of data or 1 megabyte of data, if it's zipped, it's also less network traffic in your own network. Use a CDN for static files like images, JavaScript, CSS. A CDN is basically a set of servers somewhere that you can just buy or rent that are located all over the world, very near to your users, and then they just serve the static assets for you. So the request does not, for a JavaScript file or image, does not go to your server directly. It goes to the CDN. The CDN caches it, or has it already. If it doesn't have it, it fetches it from your server, caches it, and then serves it. So you don't have much less hits and load on your server for all these files that never change anyways, or not that much, or just with every other deployment or so. And and the servers are way faster usually because they are close to your customer's location. Also, it's very advisable that you benchmark these CDN servers regularly, and maybe also test different CDN servers against each other, because depending on the regions, some CDN servers are way better than others. From our experience, for example, a lot of CDN servers or providers are not very good in Asia and South America. So if these are important markets for you, look into that. Look at your database indices. Look at slow queries, because this is usually a very easy thing to do, just creating an index, and it makes usually your page much faster. Minify your JavaScript, minify your CSS, concatenate JavaScript and CSS together. This is not needed with HTTP2 anymore, by the way. More. Send correct caching headers. If you have static content somewhere, send a caching header so that it gets cached in the browser or by proxies. Use an opcache. Just activate it in PHP. It works great. Also update to the newest PHP version, because this also gives you better performance. Think about caching data, like in Memcached, for example, or in APC. Upgrade, yeah. And then there are some more things you should look into. For example, activate HTTP2 or Speedy in your web server. HTTP2 is the newest version. Speedy is like an experiment from Google that is also supported by Mozilla. And it makes web performance, especially if you serve traffic over TLS, much faster. Usually you can just activate it. HTTP2 is already supported by Chrome, Firefox, Opera, I think Safari, and latest IE. So you should, in theory, all modern browsers already support that. HTTP2, there are many changes, it will be a whole other talk. The main thing is it's more efficient with communications and connections. So basically, what you don't need anymore with HTTP2 is any kind of domain sharding. Domain sharding means that you have your images and static assets and have them maybe of static 1.yourdomain.com, static 2.yourdomain.com, and static 3.yourdomain.com in order for the browser to fetch all these resources more in parallel, because in HD1, a browser could only open 8 connections at most browsers per domain or per host name. In HTTP2, you don't have this limitation anymore. It reuses these connections. Minimize the amount of redirects that you have. Each redirect takes time. It's opening a TCP connection, it's sending a request, it's sending a response. It's potentially DNS and SSL handshake. Don't do redirects if you don't need to. Check image compressions. There are tools out there that just go over images and that are static there and recompress them and make them much smaller. This is like 5 minutes of work. And it's good to just do it maybe once a week or so, maybe on your Jenkins CI server. Compress your HTML. What with that? I mean, you can just remove most of the white spaces there. There are also tools for that like tasks for your, for example, grunt tasks or end tasks that just do that. And this is a small optimization. It doesn't take much time to do it, and it saves you bandwidth. Check tools like YSlow and PageSpeed. These are just browser extensions, and they give you also good indications on what's maybe not ideal in your setup. If you have other domains, use stuff like DNS prefetch. It's just, for example, you have a static domain where you load images from and CSS from. Just add this to your head of your HTML, and then the browser will start doing the DNS lookup before it actually encounters a link to this image or to the CSS file. It's already a couple of milliseconds you can save there. Server side, move as much logic as possible to asynchronous workers with RabbitMQ, Gearman, or something else. What you don't have to do synchronously, like sending emails, for example, or doing cleanups, any kind of things, don't do it. Just do the stuff necessary to serve your HTML or JSON. And then there's more crazy stuff. There are reverse proxy caches like Varnish, for example, where you can say, okay, I have static content that is served by my PHP application that is usually not expiring that often, so I just add a Varnish cache in front of that, and it caches the whole HTML response and then serves it to my users. You are not hitting PHP anymore all the time. Also, Varnish supports something like edge side includes. That means if you have pages that are partly static and partly dynamic, you can just cache the partly static stuff, and the partly dynamic stuff is then fetched all the time anew. For example, if this is your application, and everything is kind of static, but for some reason this about me thing is kind of dynamic. So in your backend, what you're then running out, you're skipping this about me section here, and include an edge side include with an URL where the Varnish can later on fetch this about me component. And then you send out a caching header that is good for this profile page. So Varnish will get this profile page, see the edge side include, see the caching header. It will cache this whole thing, then resolve the edge side include, so it's going to do another HTTP request to your backend. This HTTP request then also serves some HTML content. It will replace the edge side include with this HTML content, and also respect the caching header for this request, which may be lower or even say no cache. And then on the next request to this site, it will already have all this and only do the request for this edge side include. And it also works the other way around, of course. Load content that is slower asynchronously, or content that is below the fold on your browser. That means instead of doing everything in the first request, maybe do an AJAX request later on to load content that is not visible for the users yet, or just load it when the user scrolls down, or is about to scroll down. Or if it's like a recommendation widget on the right-hand side, just load it from there. Usually the user does not notice this at all. So that means if you have this About Me component that is somewhere below the fold, instead of loading it directly, just render maybe a placeholder and then render some JavaScript later on load or on scroll or on mouse enter or something that loads the component and replaces the content in there. You also, if you're doing lots of AJAX requests for some stuff, you can also just cache them in the browser by saving the content into local storage. It is probably not good for everything, but for some things it may be viable. Either do it during the request, that is just saved in JavaScript scope, or on multi-request in local storage. Flush content as early as possible on your server application. A lot of frameworks hide this from you, but in PHP it's actually not that you get a request, compute everything, compute a response, and then send it to the client. You can flush content at any time while the HTTP request is still running. That means the time to first byte of your users, so the time the user receives the first byte, is much, much lower. That also means the browser can already start rendering stuff while you are still fetching data from your database in the backend. Move logic that you don't need to shut down handlers. Maybe, if it's not possible to do this asynchronously. That could be, for example, saving profiling data, or that you just say, okay, I'm registering a shutdown function, and then at some point I say, okay, fast CGI finish request, or just request ends, and then the response is sent to the client, the connection is closed, but your PHP script is still running, and all these shutdown handlers are executed. Think about using stuff like promises or futures. This is possible in PHP even. For HTTP calls, for example, there's a library called, I can't remember the name of the Facebook library, but there's also React PHP that you can use, where you can say, okay, I'm going to do this HTTP request, just send it, and then I'm going to do something else, like go to my database, fetch something there, and then at some point when I really need this data, I'm blocking, and then only then I'm waiting for the request to finish. In most cases, the request already finished then. Same works with PHP 5.6 with the Postgres extension. It supports also async connections. Client side, use push state, or think about using push state. Push state means that if you have a link, you can bind JavaScript on it. Then instead of going to the link and rendering the full page again, you're just fetching the difference, maybe just like the content in your site, and then you're replacing this content that you're getting with what's already on the site. So you're loading much, much less. And with push state, you can just then change the URL in the browser. So less over the wire, less computing, and no duplication in what you're fetching. And you can also make this even more crazy with a technique called big pipe. If you have a site like this, where you have a header maybe, a left column, a right column, maybe the header is the most important thing, then you want to have the left column and the right column. And you have an order in there that means you don't want to do AJAX requests to fetch that, because that would be maybe too slow, this additional connection. You can also may not want to flush everything earlier, or cannot do it. What you can do is you compute everything. You compute your menu and header, because that's most important, and two placeholders for the left column, right column. Flush it out to the server. The server already renders it. You have your whole HTML already there, everything clickable. You also flush some JavaScript to already bind stuff at the menu and header here. And then you can actually start computing the left column, and in the end render out some JavaScript that just replaces the rendered content with this placeholder. And same thing for the right column, and then flush it out to the server. This is basically the way Facebook is doing it. why they appear quite fast, even if they are really slow, because they have very complex pages. They just say, okay, in one HTTP request, we are prioritizing what we're doing. And they have other tricks with HHVM. So remember, with all of that, speed is really important, and you should measure it and take care about it. Then, thank you very much. Yeah, I think we have like 5 minutes for questions or so left. Do you have any? Yes. The question was, could I fix WordPress for everyone? No, I can't. WordPress, I have not used, the first thing is I have not used WordPress ever, for some reason. I never got to it. Are they really so slow?
I run mine with Varnish.
Okay. Yeah, Varnish would be a good thing.
I run mine with Varnish.
Yeah.
Sorry, I definitely.
If you have static content, put a varnish in front of it. Then you're not hitting WordPress anymore. Other than that, there is a company behind WordPress. Maybe, hopefully, they can fix something.
They're on it.
They're on it, yeah? Okay.
Yeah.
More questions?
Yeah. You want to take another question?
Yes?
How do you want to fix which user doesn't have to use the JavaScript enabled or a very old browser? Do you care about this?
The question was if the user has a very old browser or not JavaScript available, if we care about this. This is a business decision. So for us, it's JavaScript is mandatory. So we have a no-script tag and warn the users that the site will not work without JavaScript, because we don't see any reason to do it. The only thing is that if you can still read content on our site. So if you've just deactivated, you cannot log in, but you have the logged out version and you can read content like the publications of users. The old browsers, we are looking at the figures how many users with old browsers we have. At the moment we are not supporting IE 6 and 7 anymore, and Firefox 3. And we also have a warning. I think we even have one for, no, not for IE 8 yet, but also for like IE 6, 7 and older browsers, we have a warning that they should upgrade. A nice sentence. Here you should upgrade because it's more secure, it's much faster, it's for free, and there's actually no reason not to do it.
Cool.
Admin rights, maybe. That could be a reason.
That's the usual reason.
Yeah. Any other question? Okay, then thank you very much and enjoy the rest of the conference.